So as you see, we've got a new word up there. Well, it's not that new because I've talked about it. I said we were going to do this stuff. And everybody gets scared when you see that big word. Well, we can always shorten that word. What would you shorten it to? Trig, yeah. So most people, when they talk about math, let's everybody listen. This is the last chapter of the year, so you may want to get started off on the right foot. Do you agree? Guys, we're not starting off right. Sam, what's missing on your desk? Starting a brand new topic you've never heard of before. So what would you think you would be doing right now? Not just pay attention, but what? Take some notes. Okay, get it out. Open up. Okay, having it closed isn't going to help you. Open it up. Have your pen or pencil out. Okay, and write this stuff down. All right, this is the last chapter. All right, and it's important that you follow along right from the beginning.
This is the last chapter?
This is the last chapter, correct.
This is the last chapter.
How many? Yes, it's the last chapter in the book. It's the last chapter that we're going to do, okay? We only have 3 weeks of actual class time. Did you know that? Because the week after that, really be nice if you would listen and not. So it is the last chapter of the book. It is the last chapter that we're doing. We have 3 weeks of actually teaching in the classroom kind of stuff, new stuff, all right? The week after that is the week before finals, all right? So that's kind of like a study week, all right? So what we'll be doing is going over the stuff that we've been doing. So the final is going to only include the second semester. So I don't even know what chapter we started on. I'll look it up and I'll let you know. But that's what we'll be doing. Okay, so we got more interruptions. Oh, my goodness. Will this ever begin? Come on, quick. Have a seat. So when we refer to this topic that we're going to be doing, most of the times people just say trig, all right? If it's a real old guy, even older than me, they'll usually say, oh, we're going to study trigonometry today, all right? And that's what they would call this topic, okay? Trigonometry, trigonometry, all right? But again, we just shorten it to trig, all right? Just sounds kind of cool. Short and easy. All right, let's talk about this. Trig has to do, at least this beginning stuff that we're going to be doing right now, has to do with right triangles. We've already studied a lot about right triangles, but trigonometry, it's not all about right triangles because eventually we're going to be doing other types of triangles, but at the very beginning, we're only going to deal with right triangles, okay? And you're probably thinking, I already thought we did everything we could do with right triangles. We did Pythagorean theorem, right? If you know 2 sides, you can always find a 3rd side and all that kind of stuff. Well, we'll be doing that again. But there's some other things that we can find in here, which is really, really helpful. And that's why trig helps you out. So you can find some stuff that you couldn't find just with the Pythagorean theorem. All right, so I'm just going to draw just any basic right triangle. It's not a special right triangle because we did that stuff just recently, didn't we? The special right triangles. Yeah, 45, 45. Was it in here or was it the other class? I think it was, yeah, we did it in here. We did it in the other chapter, right? Right now in my CP class, we're doing 45, 30, 60, 90 triangles. Well, it's only a chapter behind. About a chapter and a half behind. That's why your honor's in their CP. All right, so what if you had something? Well, I tell you what. Let me just start from the beginning. I was going to go in another direction, but let's call this angle. What we've talked about this. What do we call just a basic unknown angle? Yeah, well, we say theta. All right, so it's kind of like a circle. It's kind of like a circle with a little swoosh through it, like that. Okay, it's theta. It's a Greek letter of the alphabet. We've talked about that. It just represents an unknown angle. So a lot of times we use theta. We're not always going to use theta, but in the first part of this we will. All right, so if this is theta right here, what I'm going to do is just kind of, we're just going to label these other sides. What side right here do you absolutely know the name of?
Hypotenuse.
Okay, which one is it?
Opposite of the right angle.
Okay, it's opposite the right angle. And that's good. I'm glad you used the word opposite because we're going to use that word again, all right? But this is opposite the right angle, so this will always be called the hypotenuse. So far, so good, right?
Yeah.
All right, nothing new. But here's where it's a little bit new. Now, this is not specifically a 30, 60, 90. It's not a 45, 45, 90 or anything like that, but it is a right triangle. But look at this angle right here, theta. That's the one that I've marked right here. What would I say that this side is in relationship to angle theta? Well, it looks like it's the smallest side, but I don't know what this angle is, so I can't say for sure. I might have not drawn this to scale, so I can't say that this is exactly the shortest side. Okay, what would I say? It's opposite this angle. We said that the hypotenuse was opposite the right angle, so this side right here is opposite this angle theta. Everybody with me? Yeah. All right, so here's theta. If you go right across from it, okay, directly opposite, that's called the opposite side. And I'm just going to shorten it up, just put OPP for opposite, okay? Everybody with me so far? Now, again, according to this angle theta, I don't understand why there's joking around. This is the beginning of a topic that's important, that you're going to be tested on, Sam. Talking to you, mainly. And, yeah, well, he made the noises, and I didn't sit there and just crack up. Nobody else did. You're the only one. And everybody else heard the noise that he made. Sam, how are you? Okay, you want me to tell you? You asked the question. Because you're the only one. You're the only one that responded to his silly little noise. That's why I picked on you. That's why I didn't pick on anybody else. Because you were the only one that responded to that silly noise. So, that was your question. That was your question. And that's your answer. So, sorry I picked on you because you're the only one that did what you're not supposed to do. Oh, my goodness. And I'm still wrong. I can tell by how you're responding to me. You should just sit there and say, "You're right, Mr. Hamrick. I was wrong. I won't do it again." That should be your response. It should be. Okay, enough of that. Can't believe I'm recording this. My goodness. If anybody's watching this for the first time, they're probably thinking, just get to this stuff, for goodness sakes. All right, let's do it. Let's get to it. So this is opposite angle theta. Now, what about this side right here? Now, it's not opposite. It's a word that you've probably heard before. You could think of it as a base, height and base, because it's a right angle. But it's not. We're not going to call it the base. We call this the side that's next to this angle theta right there. Do you see how it's right next to it? Okay, because it's actually formed. This side right here is actually formed by that angle, right? That side right there is made up. But a lot of you might look at it and say, well, that hypotenuse is next to this angle as well, isn't it? But the hypotenuse, it kind of supersedes the other one. The hypotenuse is super important because it's specifically what? Opposite the right angle, right? So this is always going to be the hypotenuse. Technically, it is next to this angle right here, okay? But I don't say that it's next to it. I say it's the hypotenuse. This one right here, the only relationship between this side right here and this angle right here is it's next to it. Now, I'm not going to use the word next to, but there's a word that you probably as a student, as a high school kid, hardly ever says. But you might hear old people say this. Very good. You might hear the word adjacent. So if something is next to something, like my neighbor right next to me is adjacent to me. He lives adjacent to me. Okay, Mr. Hankins, where's Mr. Hankins? Over there? So Mr. Hankins is the room, what? Adjacent to me, because he's right next to me. We share that common wall. Everybody follow me on that? Okay, so this side right here is going to be called adjacent. So I usually just use ADJ for that, but adjacent is spelled like this, in case you didn't know, right? So that's the word adjacent. Everybody with me? Yes. So far, so good. That's not so hard, is it? Let's draw another triangle. We'll just make it look the same. It doesn't have to be the same. It could be any right triangle at all, but I'm just going to kind of make it look the same. All right, it might not be exactly, but it's close enough. Still a right triangle. Now, I'm not going to talk about this little angle down here on the bottom right. Let's talk about this angle. Let's call this angle theta. Okay? Now, what I want to do is I'm going to name the other three sides. That's all we're doing right now. Okay? We got to start here first. This is the very basics. So let's talk about this angle right here. Now, what could I name? Let's name this side right here. Yeah, this is always going to be the hypotenuse. It doesn't matter which angle we call theta. This side right here is always going to be the hypotenuse. And why is it always going to be the hypotenuse? Because it's opposite the right angle. Okay, so I'll call this the hypotenuse. Now, let's take this one down the bottom. Over here, we called it adjacent. Is this one on the bottom always going to be adjacent? This is going to be opposite because we're talking about what angle? What are we referring to? We're referring to this angle theta right here. So this side, in relationship to this angle, is opposite. Everybody see that? It's super important. Okay, so if you're talking about this angle theta, then this one right here would be opposite of angle theta. Agreed? What about this little side right here? What would that be called? Right, this would be adjacent to angle theta. So in this situation, this side would be called the adjacent side. Adjacent to what? Adjacent to angle theta. Now, if I didn't mark any angles on here, I only marked the right angle, would I be able to say which one is adjacent, which one's opposite? No, because I don't know which angle to which I'm referring, okay? So, but I could always name the hypotenuse because it's always opposite the right angle. Everybody with me? Okay, so now what we're going to do is we're going to do the first real trig stuff. All right, and this is really, really important. So let's take a look. What we're going to do, let's draw the right triangle again, just as a reference. So again, I'll just make it the same. You could make it look different if you want. I'm just going to just stay consistent. All right, so here's a right triangle right here. And let's just use this angle down here. Now, let's label it again. So this is going to be the hypotenuse. What's this one on the bottom going to be? This one would be adjacent, if this is our angle theta, and this is going to be the opposite, okay? Now, we have three words. Listen, we have three words to describe a comparison. I think the reason I'm getting so frustrated is because I know how important this is. You have no clue. You just think this is just any old lesson. It's not any old lesson. What I'm doing right here is one of the landmark things that we'll be doing all through trig. And I still got people not paying attention. I think that bothers me because I know what's ahead. You don't know what's ahead, but I'm trying to warn you right now. All right? Doesn't mean it's difficult. It just means it's important. And what we're doing right here really is the crux of everything that we're going to be doing the rest of this chapter. Okay? It's the hub. You follow me? It's important. It's the foundation. Can't think of any other words, okay? But that's what it is. So let's watch and pay attention. What I'm going to do is I'm going to come up with three comparisons. I'm going to compare two sides to each other. I can compare like this side to this side, this one to this one, this one to this one, this one, right? There's actually 6 different comparisons we can make, but we're only going to deal with 3 of them, okay? 3 specific ones. What we're going to do is we are going to compare the opposite side to the hypotenuse. Now, when I do a comparison in math, what am I going to do? I'm going to compare what? Something to something. Well, that is a comparison. You're absolutely right. That's not the one that I'm thinking of. When we do a comparison, we're going to compare, like, look, if I said the class next door is twice as big as our class right here, then you would make a what? 2 to 1, right? You make a ratio, right? And if you notice the title of this, it was called Trigonometric what? Ratios, okay? So we're going to do a ratio, which basically is just a fraction, agreed? So what we're going to do is compare 2 sides of this triangle right here. And we're going to compare specifically different sides. I'll show you right now. So the first one is we're going to compare the opposite side to the hypotenuse. And then we're going to compare the adjacent side to the hypotenuse. And then we're going to compare the opposite side to the adjacent side. Okay, we're going to do a comparison. So that means we're going to make a fraction out of it. Okay, something over something else. Now, each one of these is a specific comparison. It's a specific ratio, and each one of these ratios is given a name. All right? I think years ago I looked up where these names came from. I can't remember what it was, but you could always Google it and look where they came from. But here's the words, and these are your first real trig words that you're going to learn right here, okay? I mean, opposite, adjacent, hypotenuse, that's words you already knew. But here are words that you maybe have never heard before in the context of math, all right? So the first one, the opposite over the hypotenuse, we call the sine, S-I-N-E. And what we do is we take the sine, let's scooch that over a little bit, give me some room. Okay, and we say this, we take the sine of the angle. So what does that mean? If I looked at this right triangle and I told you, give me the comparison of the sine of the angle. And you're thinking, okay, what does that mean, sine? Well, the sign means it's a ratio. The ratio of what? It's the ratio of the opposite side to the what? To the, no. Look. The opposite side to the hypotenuse, okay? So if I take this angle right here and I say, find the sine of that angle, what is that telling you? It's just like, it's a special word to just say, find the ratio of the opposite side of the hypotenuse. Because that's a lot to say, isn't it? Find the ratio of the opposite to the hypotenuse. So instead of saying all of that, we shorten it and we just say, find the what? Sine of the angle. Okay? So if you had numbers here, which we're going to do in a few minutes, okay? If you have numbers here, and I say, what's the sine of the angle? What would you do? You take the opposite side, whatever number that was, right? And divide it by what? The hypotenuse, whatever number that is. And that's the sine of the angle. Does that make sense? It's just a special word that they give to represent the ratio of the opposite side to the hypotenuse. That's all it is. It's really not that confusing. It's pretty basic.
So once we find that answer, we'll plug it in anywhere in the triangle?
Well, we'll get to that. We'll get to where we're going to use this, okay? Because this is very practical. This is very, very practical stuff. In order to find missing sides, even missing angles eventually, we're gonna use this stuff, okay? So we'll use it. It's division, right? This is a fraction. It's a division, okay? And so we'll do an example in a second. Let's just go through the rest of these. We have a special word for this one too. We don't call it the sine. We actually call it the cosine.
Oh, what a good
job. All right, since he's looking at the book probably, but that's okay. That's a good place to be. You should be looking at the book. All right, so we call it the cosine of the angle. So if I come over here and you had numbers for all three of these sides, and I say, what's the cosine of angle theta? What does that mean to you? What does that trigger in your head? It triggers that we got to find a ratio, a fraction, and what's on top, what's on bottom. The adjacent side's on the top this time, and the hypotenuse is on the bottom. That's what the cosine means. Again, it's just a word that represents the ratio, okay, or the comparison of the adjacent side to the hypotenuse. You with me? What these words mean? Okay? And we got one more. And we call it the tangent. And again, the word tangent, now we've used a tangent before, haven't we? Remember we did circles? And we said it's a line that just hits the circle. But this is different though, okay? This is different. It's not the same thing. But it's still the same word, so you have heard the word before. It's just different. But again, the tangent represents what? A ratio between two sides of my right triangle, okay? And what sides do they represent? The opposite over the adjacent, okay? So if I knew what these numbers were, okay, and I said find the tangent of this angle, then what would you do? You take the opposite side, whatever number that was, and divide it by whatever the adjacent side was, okay? And that's the tangent, yeah? Now, now I wrote the whole words out so you see what the words are and how they're spelled, but we shorten it even a little bit more, okay? So instead of saying the sine of the angle, or instead of writing S-I-N-E, they shorten it just a little bit, but they write S-I-N. Now, we don't say sin, though. We say sine, okay? I mean,
and then isn't tangent 10?
Some people actually do say sin, but that's so.
Isn't tangent 10?
It is. And so the other ones are pretty easy. So what do you think the shortcut for writing cosine would be? COS. That's right. That's the shortcut for cosine. And then, what do you think the shortcut for tangent would be? Yeah, tan. But again, we don't say tan, we say tangent. Everybody hear me? Because we want to be on the same page on this, okay? So if I said this, I wouldn't say sin theta, I would say what? Sine of theta. Okay, and usually I say of, sine of theta, all right? And then I would say what? Cosine of theta, and I would say tangent of theta. Everybody with me?
So far.
Okay, yeah, so far. That's super important. What we just did right there was really, really important that you understand where these words come from. Why do we use those words? Now, I don't know why they picked the word sine. It's probably Latin for something. I really have no idea. Okay, you could look it up. I'm sure Google will tell you where they got those weird words from. But those are the words that we use, and that's what we're going to use right here. So let's do an example now, all right, and see how this actually works. So I'm going to make it look like the one in the book, so it looks a little different. It's just this side's over here on the right instead of on the left like it was before. And now we're actually going to put some numbers in here. Okay? I'll tell you what I'm going to do right now, I think we have some time. So watch. What I'm going to do right now is I'm just going to make this easy. I'm going to make this 3, this 4. What's this going to be if that's 3 and 4? It's going to be 5, because we've talked about that, right? It's one of our, I don't know, what word did we use? Now I forget what it's called. Yeah, Pythagorean triple. That's right. Okay. So 3, 4, 5. Now, here's what I could ask you. Let's call this A, B, and C. Here's a question I could ask you. Everybody watch. So I could ask you, let's say this. Name the 3 trig ratios. The 3 trig ratios of angle A and angle B. So how many answers am I going to have here?
6.
It's going to have 6. Because I'm going to have 3 trig ratios for angle A, and I'm going to have 3 trig ratios for angle B. All right? So I didn't call it theta this time. You don't always have to call it theta, but this is angle what? Angle A. All right? So what I'm going to do is I'm going to find the what? The sine. Oh, man, I almost forgot something. There's an easy way to remember sine, cosine, and tangent. Can't believe I forgot that. It's right in my notes, and I forgot it. So here's a way. Do you see this? Watch. The sine is equal to what? The opposite over the hypotenuse, right? The cosine is equal to the adjacent over the hypotenuse, and the tangent is equal to the opposite over the adjacent. Okay, that's the beginning of the easy way to remember this. Here's what a lot of math teachers do. Okay, they use this. It's a mnemonic device. Okay, it's a word that stands for other words. Okay, but the word itself is not really a real word. It just sounds kind of cool. It's this. So what does that mean? SOH. That means the sine equals the opposite over the hypotenuse. And then we write that, and then we write this. Now, when I learned this in high school, my teacher did the tangent first. But most teachers do the sine first, so that's how we're going to do it. So let me tell you how I say it. So a lot of teachers say SOHCAHTOA, okay? SOHCAHTOA. So if you can remember SOHCAHTOA, you should be able to remember your 3 trig functions or ratios. Okay? Let's everybody say it on 3. Ready? 1, 2, 3. SOHCAHTOA. All right? So I kind of jokingly, half jokingly anyway, when you're going through the hallways and you see each other, you should greet each other now and say what? SOHCAHTOA. All right? You say SOHCAHTOA enough. Listen, if you say SOHCAHTOA enough, you're going to remember your trig functions. So if I say SOHCAHTOA, what does that mean? It means the S, the SO, is SOH, which means sine is opposite over hypotenuse. Remember, they're over, right? It's not times like this, but it's over the hypotenuse. The cosine is the what? Adjacent over the hypotenuse. The tangent is the opposite over the adjacent. Okay? That O is, it looks like a theta, but it's supposed to be an O. All right, enough of that. Let's go back to this. So I want to find the sine of angle A. I want to find the cosine of angle A. Oops. Sorry about that. It's weird looking. And then the tangent of angle A. And then I want to find what? The sine of angle B.
The
Cosine of angle B. And then the tangent of angle B. Now, again, this is only a start. We're only learning this stuff in order to find something else a little later. Okay? This is just the beginning. It's just foundational stuff. So what is the sine of angle A? Well, here's angle A. What is the sine? SOHCAHTOA. So. What's the so?
The sine opposite
over hypotenuse. Right. So watch. Look at angle A. Which one is opposite and which one's hypotenuse?
3 is opposite.
3 is opposite and 5 is hypotenuse. There you go. You've done your first trigonometric ratio. All right? Aren't you happy about that? The first of many. What's the cosine? It's the cos, C-A-H. Adjacent over hypotenuse. That's right. So you're still using angle A. Which one is adjacent to angle A? 4. And which one is the hypotenuse? It's 5. What about tangent? What's TOA? TOA is, just in general, it's opposite over adjacent. Opposite over adjacent. So that would be what? 3. No, TOA. T-O-A. No, TOA. T-O-A. Opposite over adjacent. So that's what the sine is. That's what the cosine is. That's what the tangent is. Now, we're not going to do this today, but listen to me. You guys are wound up today. Settle down. Settle down. It's Monday. For goodness sakes. Monday, you're supposed to be quiet and everything else. Usually. Friday is the day everybody goes nuts. Monday is supposed to be a calm day. So look. Notice, I don't know either one of these angles, do I? I don't know angle A or angle B. Before today, well, we're actually not even going to learn it today, but I'm just going to hint to something we're going to learn a little bit later, okay? Before we learn this stuff, there's no way to find out what angle A or angle B was. Now, if I knew angle A, how would I find angle B? If I knew this was 30, what would this be?
Oh, 60.
Why?
Because it's right triangle, special right triangle.
Yeah, it's not because of special right triangles, because these two angles do what? A and B add up to what? 90 degrees, that's right. So if you know this, then this is 90 minus whatever that is, okay? But the thing is, before today, there was no way to find what angle A was just with the sides. There was no way. We had to know one of those angles, agreed? Right? But learning this stuff, we're actually going to be able to find what angle A is, and we'll be able to find what angle B is, right? With only knowing the sides of the right triangle. I don't know any of the angles except for the 90, okay? But knowing this stuff, I'll be able to use actually any one of these trig functions, and I'm going to be able to find what angle A is, all right? We're not going to do that yet today, okay? I just want to show you what eventually we're going to be doing. So I think that's kind of cool. All right, let's do this. Now let's go to angle B and find the trig ratios of angle B. Is it going to be the same as the sine of angle A? No, because the opposite and the adjacent are going to be two different sides, aren't they? Yep. Hypotenuse is still going to be the same, but the opposite and adjacent will be different. So again, the sine. Let's, in our head, what's the sine? The sine is opposite over hypotenuse. So angle B, which one's opposite? No, listen. Which one's opposite angle B? 4 is opposite angle B. Okay? And of course, the hypotenuse hasn't changed. That's still a 5. What's the cosine? Go through the little device. It's the ca, right? So ca toa. It's a C-A-H. So it's the adjacent over the hypotenuse. So again, what's adjacent to angle B? The 3 is. And again, what's the hypotenuse? It's 5. What's the tangent? The tangent is TOA, T-O-A. What is it? Opposite over adjacent. TOA, T-O-A. It's opposite over adjacent. So what is opposite angle B? 4, and the adjacent is 3. So it's 4 over 3. Now, this in and of itself doesn't really help us find anything on the triangle. Would you agree? But it will. Okay, eventually. I don't know what lesson they do it in, but eventually we're going to be able to use this stuff, and we're going to be able to find angle A and angle B. Everybody with me? Okay, we're not done. Let's do a real example here. It's a little bit tougher than what we did, but it's very similar to what we just did. So that wasn't officially in the book. I just did that just to kind of get you thinking a little bit. No, it's not. It's not the same. If you look at it, it's not the same. It's not 3, 4, 5. Example 1 is not a 3, 4, 5 triangle. Oh, and the homework. Okay. Well, maybe in the homework it is. All right. This is the example. This is example 1. And they ask you basically just to find that, like, we're just doing angle A right now. We're not doing A and B. You could do B if you wanted to, but we're going to do the same thing. We're going to find the trig ratios, the trigonometric ratios of angle A. All right, so what does that mean? It means we find the sine of A, we find the what? The cosine of A, and then we find the tangent of A. Now this is a little different. Why is this a little different?
Because we don't have AC.
You don't have AC. Let's give it a letter. Is that all right? They don't do this in the book, but I'll do it. We'll just call it X. All right, you with me so far? So now, if I want to find what is X to angle A, is it opposite? Is it adjacent? Is it hypotenuse? It's adjacent, right? So all the ones that have adjacent in them, which are what? The cosine and the tangent, they both have adjacent, right? I'm going to have to know what X is in order to find the cosine and tangent. Now, I could find the sine right now. Because again, what's the sine? It's the what over what? Opposite over hypotenuse, okay? So it's angle A, so which one is opposite? 5. And which one's hypotenuse? 9. So you're done with the sine of angle A. But if I want to find the cosine of angle A, I have to find the adjacent over the hypotenuse, and I don't know what the adjacent is. So how do I find the adjacent? What is it? Plug it in? I can't just plug it in. I got to find it. Okay. Pythagorean theorem, exactly right. Do Pythagorean theorem. How do I set up this Pythagorean theorem? Yeah. I'll do the x first, though. X squared plus 5 squared equals what? 9 squared. So let's do it real quick. X squared plus what? 25 equals 81. My writing's terrible. At the bottom of the screen. How do I do this? Subtract 25, and what's that? 56, right? 56. X squared is equal to that. So x is what? The square root of 56. Everybody with me so far? Okay. Now, we got to simplify this. What times what is 56? You may not know, but it's 4. Yeah, 7 times 8, but you could also go 4 times 14. So what's this? It's 2 square root of 14. See that? Square root of 4 is 2. Square root of 14. So that's the best way to write it. So what's x equal to? 2 times the square root of 14. All right? So this one's a little harder, not because of the trig stuff. It's the same exact thing as we did just a minute ago, but because, yeah, you got to find the other side. Okay? So now, let's go ahead and find the trig stuff. What's the cosine? It's adjacent over hypotenuse. Which one's adjacent?
2 square root of 14.
2 square root of 14 over the hypotenuse, which is 9. Does this simplify? No, nothing cancels out. 2 doesn't go into 9. So that would be our answer right there. Now, they also ask you to write it as a decimal approximation. And they ask you to put it, they don't ask you, but they do, put it into 4 decimal places. So we got that. See how I put a squiggle, equal sign? 8, 3, 1, 5. Okay? To tell you the truth, I would prefer this right here. But they ask you to do both, so we'll do both. Now, how do I find the tangent? The tangent is what over what? So what is it? Opposite over what? Okay, now here's a little issue. You remember this earlier in the year?
No.
What's the problem with this? You can't have a square root in the denominator. That's right. Okay, so what do we have to do? Not by 14, by the square root of 14. Okay, now watch. Write it down if you're not following along. So it's 5 squared root of 14 over, what's this? 2 times 14, right? Square root of 14 times square root of 14 is 14. Let's do that in our head. 2 times 14 is 28. So, does anything cancel here? No. Square root of 14 doesn't simplify. All right, so that's your answer. And if you put it into a calculator, you get 0.6682. 6682. All right, so they asked for both of those answers right there. Okay, you with me on that? Now, there is another example in there. Yeah, I'm going to have to talk about it tomorrow. I don't have enough time today to talk about that. Example 2 is a little bit different. It's really not that hard, but I need 4 minutes to do it, and I have less than 1 minute right now, so I can't do it now. But anyway, there you go. I gave you the lesson plans. So you're doing a 1 to 18. There may be a few on there that you can't do because we skipped that one lesson or that example. But you're doing 1 through 18 on 12-1. All right, that's it. Have a seat till the bell rings, please. There you go. Now you can go.